is the basic MPLS. We have learned the basic MPLS very well, very well. It was not very difficult for us to understand. And the configuration was also not big in this difficult thing. It's just one command, MPLS IP. And we were also setting the range of labels on each router. Those things are optional. Now, this MPLS along with BGP can do something more. What is that? We can have layer 3 VPN. So MPLS along with BGP, say I don't want to say simply BGP. I would like to call it as MPBGP. When I say MPBGP, you should not understand that it means MPLS. No. It is not. MPLS assigns label to all those routes that are there in the router. Now, MPBGP is a general term. But here also multi-protocol, here also multi-protocol. But this multi-protocol label switching is talking about label in layer 2.5. This is not talking about layer 2.5. This is totally different. This is not that label thing. This is not that label thing. So that MP and this MP is not same. Here also it is MPBGP, multi-protocol BGP. But what it really means is BGP supports multiple layer 2, layer 3 protocols. For example, VXLAN EVPN. What is that? VXLAN EVPN. It is one of the MPBGP. It is one of the MPBGP feature. It is one of the MPBGP address family. Like VXLAN EVPN in BGP, you also have segment routing. We also have layer 3 VPN. You see, that is why the name MP. This BGP has got different address families. One address family is to support layer 3 VPN. The other one to support VXLAN EVPN. The other one is to support segment routing. The other one is to support IPv6. This is the reason why you call it as MPBGP. So when I say MPBGP, it's a global name. So if you need to be very precise, then you need to say L3VPN BGP. BGP support to create L3 VPN. All right, that is what in really we have to say. L3 VPN BGP. But not many people will tell like this. They'll say MPBGP. They will say MPLS with BGP. All are same. No problem. Can be said. You can say MPLS with BGP can provide L3 VPN. True, but partially true. Why? MPLS with BGP can do many things. It can even do MPLS with VPLS. MPLS with BGP can also provide layer 2 VPN. So you cannot simply say MPLS with BGP can provide layer 3 VPN. That may be correct, but other correct, half correct, not fully correct. because MPLS with BGP can also provide L2 VPN, Virtual Private LAN Service, VPLS. So the most appropriate term that we can use is L3 VPN BGP. BGP support for L3 VPN with MPLS only. With MPLS only, BGP can provide you L3 VPN support. L3 VPN support. Without MPLS, BGP can't do this. Why? BGP is going to use the labels, not the IP address inside the tunnel. So the control plane is again labeled for this L3 VPN BGP. That's why you need MPLS. For this VPN, we are going to create a control plane. You may ask, like, what is that control plane? See, it's a layer 3 VPN. Then it is routing table. Routing table is the control plane. The routing table is the one which controls the direction of the traffic flow. So it's a control plane. Then you may ask, like, we already have routing table. Yeah, you already have routing table, but that is not the routing table for the virtual private network that you're going to create. That control plane is for the physical network, which is already there in ISP. That routing table that you already have is for the physical network of the ISP. Let me draw it and explain you. You see, this is your ISP. And ISP has got for VPN we have a separate routing table. For physical network of the ISP, we will have another routing table. Of course, the layer 3 VPN is the overlay. Correct. You can call it as overlay. All VPNs are overlay. You're right. You see, this is your ISP. Let's say BGP Autonomous System 1008. Now, to reach between this provider edge 1 and provider edge 2, to reach between these two, you will have a routing protocol inside, maybe OSPF. So once you have the reachability using BGP layer 3 VPN, you can negotiate a tunnel. You can negotiate a tunnel. This is what L3 VPN BGP. Fine. Now this tunnel is for whom? Is for the customer who is going to be connected here. That's why it is called as PA router. Customer is here. CA router. Let's say customer is an autonomous system, BGP 10. And that same customer remote office is connected here. This may be BGP 50. Now, whatever the customer advertises, the route advertised, will go only through this tunnel and get delivered to the remote office. So that using that route information, this remote office can reach the local head office. This branch office can reach the head office. So you need a separate routing table to maintain the routes of the customer, so that that routing table alone can be connected to the VPN. If you connect the normal common default routing table to the VPN, problem. What problem? If you don't have separate routing table, what is the problem? Then it is not VPN, because the customer can get into all the business of your inside network, and your ISP also will come and play with you. Inky, pinky, ponky. Danger, no? ISP coming into our network, we going into ISP network. It's dangerous. So we need a separate control plane for the customer, and customer physical network, physical wire, and the VPN will be connected to one routing table here, which we are going to create. We are going to create this routing table. We are going to create this routing table. When you create the routing table, it will be attached to the VPN and customer. So customer's physical link and the VPN for the customer is interconnecting, is getting together in a meeting place called VRF. VRF is nothing but customer's routing table, virtual routing and forwarding. VRF. So VRF is the control plane. VRF creates a routing table and keeps the customer's routes that's supposed to go inside VPN separate from the default routing table, which contains the provider's network. So we need VRF. We have to create VRF. Simply enabling VPN without VRF won't work. I repeat. If you create a layer 3 VPN using MPBGP, it is of no use if you don't have VRF. Why? VRF and VPN will work together. VPN cannot work independently without VRF. This I'm telling to Cisco guys. You are Cisco guy. But other vendors are not like that. Other vendors, they are very clear in their commands. They don't call it as VRF, they call it as VPN instant. The name itself is very clear that it's the instant of VPN. It's the control plane of VPN. A control plane instant created for VPN. So the command itself will very clearly say that it's the VPN control plane. It's a VPN control plane. We don't have confusion there in other vendors. Other vendors don't say VRF, and then VPN, and then you connect together. No statement like that is needed when you teach other vendors. Other vendors will be very clear. What is the word that you use there for VRF? They use VPN instant. When you create a VPN instant, of course you understand that it is going along with MPBGP VPN. Anyway, you are in Cisco, so you don't need to worry about the VPN instant thing. Now you need to just take a note of this one. What is that? We have a control plane created using VRF, and that VRF is connected to the VPN. And you need to just take that customer interface, put it as a member of the VRF, so that the customer physical interface and the VRF, which is an overlay, they can mingle, they can get mixed, they can unite, they can join, they can meet in a common place called a routing table of the customer. Routing table of the customer is the VRF. That is the meeting point where the VPN and the customer interface meets. The overlay of the ISP and the customer facing interface of the Edge PE router meets. Did you understand what is VRF? For each customer, ISP has to create VRF. Hmm. Correct. Correct, sir. So if you have more customer, then more VRFs, more control planes. Each customer will have their own VRF. Any question from Bala? As I said, each VRF, each VRF is a separate control plane. So when a customer advertises, those advertisements go to their respective routing table. Now the routing table is identified with an ID which we call it as route distinguisher. I repeat, each customer has got a separate routing table. What is that called as? VRF. So when the routing table is separate, then the routing table needs an ID to identify, right? That is what we call as a route distinguisher. So the route distinguisher will tell whose network advertisement is this one. So when this customer advertises, that will be identified with a different ID. And this is another customer here, a blue customer, and his route is in separate another routing table. And by default also there is one global routing table. So to differentiate that blue and pink, here I say blue, pink, but in networking we cannot say blue and pink. And what do you have? We have route distinguisher. What happened? You're not completing the statement. We have route distinguisher. Route distinguisher, see the name very clearly says it distinguishes. It distinguishes the routes of one customer from the other. No, VRF ID is a name. It's an English name. That is not. That is not. That is for just for configuration. But what is important is this route distinguisher. It is a 64-bit value. A route distinguisher is 64-bit value. And route distinguisher is separated using a colon between every 32. Like 64, I say route distinguisher is 64. That 64-bit is like 32-bit colon 32-bit. Sorry, not colon, I think it is a dot. 32-bit dot 32-bit. 64 in total. And this 32-bit can be the autonomous system of the neighbor or can be the IP address of the neighbor, because it's 32-bit now. You can put autonomous system number or IP address. Here also, you can put the IP address or the autonomous system. There is no strict rule. Hope you understand what is route distinguisher. There is another term called route target. See the word target. What is it? When this pink advertises, it should go only to the remote pink routing table, which is here. It should not go into the blue routing table. So to exactly deliver to the correct routing table on the remote router, they use route target. So when this pink send, it will send with a number, and the same number will be here. So they know what to download and what not to download. When the pink uploads, it uploads with a 64. That is also route target is also 64-bit, 32-bit, 32-bit. Say for example, pink is using 1:1. Yeah, it is not dot, it's colon. 1:1. He's exporting with 1:1. Here, this will be importing with 1:1. That is how you can deliver the update to the right control plane on the remote. That is why it is called as remote target. To identify the correct routing table on the remote router, we use the value called route target. And the route target value should match. The export and import value must match. All right. So that is route target. Route distinguisher is local to the router. Locally, to differentiate from which customer it is coming, whether it is coming from blue or pink, you need route distinguisher. Route target is global. To decide to which remote control plane to deliver, you need route target. Yeah, so route distinguisher, route target. These are the two things which will confuse many when it comes to VPN. I hope this will not confuse you. In our tomorrow's class, we are going to do a lab on this. Then you will be more clear with this. It will be very easy for you when you learn like this step by step. When we learn everything in one day, this is going to be a difficult task to do the lab. All right. So I'll stop here.